Here's a nice example relating back and trying to calculate force and also the direction of the force due to a magnetic field which is present. So let's take a look and see how we would tackle something like this. So a particle with a charge of negative 5.5 millicoulombs is traveling at a speed of 990 meters per second in the xy plane. The particle is traveling at 45 degrees with respect to the x-axis. A magnetic field of 2.1 Tesla in the direction of the y-axis is present. All right, so what is the direction and magnitude of the magnetic force, okay, on that particle? Let's try to draw this out. So the given pieces of information are, so this is the xy plane, so I'm gonna just normally structure my xy plane here. Okay, let's try to make it, it's my y, here's my x. Okay, so this is what I would have. And then as this is as a reference, now it's negative 5.5 millicoulombs and it is traveling at 990. So we have all of those. So in terms of the charges, so I'm going to put negative 5.5. Let me maybe change that around. So this would be, approximately, so let's say 45 degrees. Okay, so this is 45 degrees. This is my charge Q. Okay, so as it travels on, so this is the direction of the velocity right there. And then the magnetic field, which is 2.1, and that's in the direction of the y-axis. All right, so on the y-axis, so this would have been looking like this. Okay, so I'm just going to draw it like that. And that's going to be my magnetic field. And we know what that strength is. All right, so we have that. So therefore, the angle actually in between them is also 45 degrees. So that will be something that we're going to need. So now I need the direction and I need the magnitude. Okay, so within here, so in terms of the direction, so the first step is, you take your right hand and then you curl it towards your magnetic field. So I'm gonna let you do that. So as you're going through, and then I'll put a picture there for you just so that as the curling goes through. So we're gonna be curling in this direction. And if you do this, I guess I'll try to draw out here. So this is gonna be the 3 dimensions. Okay, so this is my z-axis over here. So that's gonna be kind of out of the page that you would have. Now, out of the page would be, but that would have been for a positive charge. So therefore, your negative charge, because this is negative, notice, that means that's going to be into the page. So as you're going through, so if you're using your right-hand rule, it's going to be completely on the opposite side. So that means this is going to go right into the page right there. So let's do it like this. Now, of course, this happens so within here, so as it goes through, so it would have been into the page at that instant. Okay, so we have the direction, so within here. So if you set this as positive, so that means the direction is going to be in the negative side of the z-axis. Now we need the magnitude. So the magnitude is much simpler. So we can just take this. Now I'm going to change. So notice it's 5.5 millicoulombs. So I'm going to change this to coulombs. I don't need the negative within here because I just need the magnitudes. This is 990 and this is 2.1. Now we need to multiply all of this by sine of the angle. So sine of 45 degrees. And there you go. So we have the direction and then we're going to have the actual calculation. So let me do that. So there you have it. All right, so I rounded it to 2 significant figures just because the question, that's the minimum amount there. All right, so that is it for this example. Okay, so I hope you found this useful. Bye, everybody.